The objective of this lesson is to solve real-world problems concerning volume. In previous lessons, students have learned how to calculate the volume of rectangular prisms by multiplying the length, width, and height. Today, students will extend their knowledge to calculating the volume of shapes by decomposing the shapes into rectangular prisms. There are many solutions for the problems in the lesson. Let's begin with the first problem. How much more three-dimensional space does the refrigerator take compared to the cooking range? Let's begin by calculating the volume of each appliance by using the formula volume equals length times width times height. The refrigerator's volume is 2 5/10 feet times 2 7/10 feet times 5 9/10 feet, for a total of 39 825 thousandths cubic feet. The cooking range's volume is 2 4/10 feet times 2 5/10 feet times 3 1/10 feet, for a total of 18 6/10 cubic feet. Next, subtract the volume of the range from the volume of the refrigerator. 39 825 thousandths subtract 18 6/10 equals 21 225 thousandths cubic feet. Now, let's solve another problem that is just a little more difficult. The Jensen family just had a pool installed and is excited to fill it with water for the first time. Using the measurements shown, if the pool is 4 feet deep, how much water could the pool hold? The pool is not a rectangular prism. However, it can be decomposed various ways to create rectangular prisms. One way to decompose the pool would be to create 3 rectangles like this. Now the area of each rectangle can be multiplied by the depth of 4 feet to find the volume if the pool is filled with 4 feet of water, because volume can be found by multiplying the area of the base times height. The top rectangle's area is 21 times 4 5/10 feet, which equals 94 5/10 square feet. The next area in the lower right portion of the pool is 12 feet by 12 feet, which equals 144 square feet. In order to calculate the last rectangle, the width must be found first. The width of this last rectangle is the 12 feet minus the 4 5/10 feet already counted for in the first rectangle, which equals 7 5/10 feet. 7 5/10 times 12 feet equals 90 square feet for the area of the last rectangle. In order to calculate the volume, each area can be multiplied by 4 and then added, or each area can be added and then the total can be multiplied by 4. Both methods are correct. Let's get a total area for the base of the pool first and then multiply by 4 feet. 94 5/10 plus 144 plus 90 equals 328 5/10 square feet. Now multiply the total area by 4 for a volume of 1,314 cubic feet of water is needed. Another way to break the pool into rectangles would be to calculate the whole pool as a rectangle, then subtract the small pieces that are not a part of the pool. The total length of the pool can be found by adding the 12 feet length here and the 12 feet length here for a total of 24 feet. The width of the whole pool is found by adding 12 feet plus 4 5/10 feet for a total of 16 5/10 feet. The total is 24 times 16 5/10, which equals 396 square feet. Now let's find the areas not included in the pool and subtract them. The first area in the top right is 4 5/10 by 3, which equals 13 5/10 square feet. The second area to subtract is in the bottom left. It is 12 feet by 4 5/10 feet, which equals 54 square feet. Now subtract the areas not included in the pool from the total area found. 396 subtract 13 5/10 subtract 54 equals 328 5/10 square feet total area for the base of the pool. Multiply the base times 4 feet for a total volume of 1,314 cubic feet. The objective for this lesson was to solve real-world problems concerning volume. We met this objective by solving the volume of different shapes using the formula volume equals length times width times height. We decomposed a pool into various sizes of rectangles in order to find the volume using the formula Volume equals the area of the base times height.